Hello and welcome back. So in this video, we did our even-odd program with if statements. This time we're going to do this with switches. And there's going to be benefits and differences in both of them. The benefits and negatives to both of them. So let's just try, I'll put a 2 in here. Numbers even. Let's do this again. 1, numbers odd. This time, let me try and do the hibbidi blah blah blah. And once again, it says number is even. But this time, if I try like a 1.2345 whatever, or if I do this and say blah 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 blah, enter, error, not a one-digit number. So we do have ourselves a little bit better of an error tracker in this one, but it's going to have different sort of problems as well. It's, 6 in one hand, half a dozen in the other. So what we're going to do here is, once again, we're going to go back to our good friend JDoodle, get rid of, oops, not get rid of that part, but get rid of this part. And we're going to start out once again by welcoming everyone. So C out. Welcome to the even/odd program switch version. Because this time instead of using if statements, we're going to use switches. Switches work a lot like if statements, but they're going to be slightly different. So as always, I'll just do an int and I'll make a my number because I'm going to add it in. And of course, C out. Enter a one-digit, one-digit long whole number. Okay, now the reason why I specify one digit here is because it's going to be very time-consuming if we wanted to do something, to try to incorporate every possible number. We would have to do something weird where we'd only track the last number they type in, not the first or second or anything in between, which means we would have to figure out the length of the number, and then we'd have to go and find the very last digit and only care about that one. But we're not good. We don't have the time to worry about length and all that sort of fun stuff. So we're just going to make this a one-digit program. Now, obviously, as you can see, that can give you errors if you type in a number that's not one digit. But, C in, oops, my number, and there we go. So we have the ability to type something in. So, instead of using ifs now, we're going to use switches. And I'm just going to use the word switch. Oop. When it feels like typing. Switch. And what am I switching? I'm switching my number, because my number is what I typed in. And there's different possible variable states that I could have. And I'm just going to tab this over just to make it look pretty so you see it. But what possible cases? So switches, you define each case individually. So if you were to say if something something equals 0, well, that's case 0, colon. If you were to say something, if case 2, colon, that's I'm checking to see if my number equals 2. If I'm saying case 4, I'm saying, hey, check to see if my number double equals 4. Case, 6. So that was not a 6, that was a 5. Case 6. And case 8, because I used double equals. Okay, I said one digit long. Now, here's the problem. They can theoretically still type in more than one digit. So, I would have to do a case 12, case 14, all the way to infinity. Now, do you think I have the ability to actually go all the way up to infinity? No. That's why I said, realistically, if we were to make this an error-free program, we would have to check, we would have to do something where even if they type a really long string of numbers, we are going to only care about the last number, which would involve checking the length of the string and then only checking that last bit. Okay, that's all it would be. So, obviously, we're not going to do that. But, considering that's the case, I'm going to do and say cout number is even /n/n. You know, just for space. So now, obviously, if I were to do that, and I say, I'm sorry, what did you have a problem with, case? Oh, because I put a colon there instead of a bracket. There we go. Now that will work. Remember your squiggly brackets. So now enter a one-digit whole number, 4. Number is even. But, of course, if I were to do a 3 here, nothing happens because I haven't made those cases yet. So, let's make those cases. And you know what? I just like indenting things just so I can see that this belongs this belongs inside this. This only happens when this is true. This only happens when this gets to, you know, I like doing stuff like that. So I like doing that just to make sure that everyone can see what it is that I'm doing. I recommend you get into a habit of making stuff line up in a way that you understand it and makes sense. Because you don't want to look at that giant block of code and go, I can't find where anything is. So count. Okay, obviously, number is odd. /n/n. So now, if I execute this, because I have the cases for odd numbers, if I do a 3, it'll go and say the number is odd, like the way it was. So none of these were true, so it skipped this. But these guys, one of them was true, so it did this. Now then, obviously, let's have ourselves a situation of everything else. So if these are all like else ifs, every single one of them is basically an else if, well then, let's do a default. Default is everything else not specified by the cases. So much like this is the everything else, okay? I will say count error, not a one-digit number, /n/n. Now then, you think all of this looks perfectly fine. It's not. So I'm going to purposely enter a one-digit number, 2, and it will now say number is even, number is odd, error, not a one-digit number. So, why did it do that? Now you see, here's the thing. It will in fact do everything. Okay? So I add a 3 here, number is odd, error, not a one-digit number. The minute you put a default in, it's going to go and say every possible answer. So in this one it was odd, so it was odd, and there's a default. The default will always happen. So, these guys differentiate itself in one way. If stops at first true answer. Switches do not. So if there's more than one correct answer, a switch will give all of them to you. So, how we're going to do this, how we're going to stop it from doing this. The word break. And you know what? We probably don't need one at this point down here since that's the end of the thing anyway, but we'll do it anyway. Break is literally a break in the logic. Basically, think of break as shutting it down. Break stops an object. So basically, if we hit this break, it goes stop, stop this, stop the code, end it. So, and of course, just for, even though I know it's not going to work, return 0 in JDoodle, even though it will work in Xcode. Enter a 1-digit long number. Now if I hit a bizarre long number, it won't tell me it's even or odd. It'll just tell me error, 1-digit number. So it'll only do those parts because we broke it. Now if I only do a 4, it will only say it's even. If I only do a 5, it will only say it's odd. There we go. It's working. So, in this week, you've learned the differences between switches and if statements. And we've done basically the same program. There's some errors here, like obviously if I still say, if I still put a W, it'll just say number is even and it'll just stop me. That's its go-to stopping thing of going, nope, you entered a 0. But, so that sort of feature still exists in both versions. But we've learned some logic this week. And if, else if, case, break, switches, all that sort of fun stuff, defaults. So we've done all that. So save this, submit it through Moodle. Hopefully you saved and submitted the other one through Moodle too. I will see you on Thursday. Thank you, everyone. Have a great time.